Hello everyone, myself Sowmya, Assistant Professor in CSE AIML Department, MLR Institute of Technology. In this video, we are going to discuss about block in blockchain. So coming to the overview of this presentation covers what is a block in blockchain, what are the different sections available in the block, and what is a genesis block. So first of all, we are making the term as blockchain. What is this block and what is this chain? So blockchain is nothing but we have another definition. It is a chain of blocks. But what is a block here? Block is nothing but it is a record that contains the transaction data details. So block is nothing but it contains transaction details. So what is this transaction and what are the different sections available in this block? So the block will contain all these fields. The first field is hash of the block. So we know each block is identified using a hash address, hash of the block, and this hash you are generating using SHA-256 algorithm. So every hash address is it's containing 256 bits. So this hash will provide the uniqueness for this block. If I have 100 blocks, then each block will be having some unique address, and that unique address you are calling as a hash of the block. And next is hash of the previous block. For example, if I have 2 blocks, then the second block will contain the address of the previous block also. So for the first block we don't have any previous block, so that's why the previous block address will be empty. So like that, if I have third block, this block will contain the second block address. So why we are linking like this? It is a link between the nodes. And one more thing is, so why we are maintaining the hash of the previous block? So while calculating the hash of this current block, second block, it will also use the hash of the first block. The same way, to calculate the hash of third block, it will use the hash of the second block, and after that it will also apply some algorithm to calculate that. So like this the chain will be formed, so that if you want to find out the hash of the nth block, you should know the hash of the n-1 block. So this will provide the security for your blockchain also. Why? Because if the intruder or if the hacker wants to modify some transaction data in block 3, then automatically the address of this hash of this block will be changed. Why? Because for every message there will be a unique hash value. So if the user or if the intruder wants to change this data, automatically the hash will be reflected. So this hash will be reflected to the remaining blocks also. So third block onwards, 4, 5, 6 and so on till nth block, the hash code will be changed, so that we can easily find out where the hacker is attacking the block. Of course, it's not possible in blockchain. We cannot modify this data. Why? Because the data is immutable here, but still if the user wants to modify like this, then it will affect the remaining blocks also. So that's a use of hash of the block and hash of the previous block. So by maintaining the hash of the previous block, no hacker or no intruder can modify the transaction data. And next is timestamp. So when you have created the transaction, in the block we have set of transaction. So at what time you are creating this transaction, that timestamp will also be stored in the block. And next is nonce. So nonce is nothing but it's a random number used to vary the value of the hash. So we already know the hash value will provide a uniqueness for each block, but along with that, to provide more uniqueness for a block, we are also maintaining nonce. So nonce is a random number which provides uniqueness for your block along with the hash. And next is Merkle root. So Merkle root is nothing but it is hash of all the nodes, all the transactions in the block. For example, if I have 10 transactions in a single block, so the hashes will be 10 hashes. So for these 10 hashes combinedly, I will calculate one more hash, and this hash you are calling as a Merkle root. So Merkle root is nothing but hash of all the other hashes of the transactions which are available in the block. And next, the last thing is transaction data. Along with all these details, the block will also contain the transactions details, that is nothing but records. So this is a simple structure for a block representation. So the first block, second block, third block, fourth block and fifth block and so on. So the first block you are calling as a genesis block, and after that you are giving the number as block 1, block 2, block 3 and so on till block n. So each block will contain the current block hash, previous block hash, timestamp, nonce, Merkle root and transaction. All the blocks will contain this data. Of course, genesis block will also contain all these data except this previous block hash. So what is this genesis block? The first block of the blockchain is called as genesis block, and in the genesis block the previous block hash will be empty. Why? Because it doesn't have any previous block. So what is genesis block? The genesis block is the first block. It is the only block with no data hash of the previous block, because there is no previous block but that genesis block. And the genesis block contains transactions that are combined and validated to produce a unique hash. So like other nodes, the genesis block will also contain the transactions. It will provide a unique hash for that block. So that block will contain hash, but it doesn't contain the previous hash. Why? Because we don't have any previous node for that. The genesis block hash along with all the new transactions are processed and used as input to create a new hash that is used in the next block, that is block 1. So whenever you calculate hash of this genesis block, that will be used to calculate the hash of the block 1. See, if you observe in the previous figure, so here we have some block hash. This will be used to calculate this block 1 hash. The same way, the connecting block 1 hash will be used to calculate the block 2 hash. Block 2 hash will be used to calculate the block 3 hash and so on till nth block. So in the same way, block 2 hash is created with a hash of block 1 and another set of new transaction. So the value of this transactions will be considered, as well as the previous block hash will be considered to calculate the current block hash value. So because of this continuous linkages, makes it is impossible for any malicious actor to alter the information or to insert a block between the two existing blocks. For example, I have two blocks, so the hash is some x here, the hash is some y here. So how you are calculating hash of y? It is using x plus the transactions it is using. Now if I modify this transaction value for x, this value will be changed. So whenever this value will be changed, automatically the y value will also be changed. So because of this feature, no malicious actor can alter the transaction value. In the same way, he cannot even insert a block in the middle of two other blocks. Why? Because these two are already interlinked. So we cannot connect these three things here. So because of this feature, each block strengthens the previous block. So the next block strengthens the previous block. So if I change any one block here, automatically the next block's addresses will be modified. So that is about block in blockchain. Each block, what it contains timestamp, transactions, block hash, and what is the genesis block, right? So all these things we discussed in this video.